So let's further our understanding into sets and subsets of real numbers. When we talk about subsets, we're talking about sets inside of other sets. That's what subsets means. And so we're going to take a couple of statements and try to determine if these statements are true or false. So the first statement we have is that all irrational numbers are real numbers. So what we want to do is come over to our diagram that we have here and find irrational numbers, which are right over here on the right side. There's irrational numbers. And the statement says all irrational numbers are real numbers. So what the statement is asking is, if we have an irrational number, does that automatically mean that it is a real number? When you're looking at the diagram, it's a very simple question to answer. Is the set of irrational numbers inside of the set of real numbers? So if we look at real numbers is this entire box right here. Is irrational numbers inside of the real numbers box? And the answer is yes. So the answer to this question would be yes, every irrational number is in the set of real numbers. Because if we're in that irrational numbers box, we're automatically inside the big real numbers box. Okay, let's take a look at the next one. No rational numbers are whole numbers. So let's go look at our rational numbers section. Rational numbers is over here on the left. No rational numbers are whole numbers. So whole numbers is right down, let's get a different color here. Whole numbers is right down in here. No rational numbers are whole numbers. So this is worded in kind of a confusing way, but what it's asking is, if we have a rational number, could that number also be a whole number? Could we have a number that was a rational number and also a whole number? And the answer is, of course we could. In fact, every whole number is also a rational number. So if I said, hey, I have a rational number here, could you say, oh, well, then I know it's not a whole number? Of course you couldn't, because what if my rational number was 1? If my rational number was 1, that is also a whole number, so we can come up with immediate counterexample. A counterexample means an example that disproves the statement. So it says no rationals or numbers are whole numbers. We could say, no, this statement isn't true. 1 is a rational number. That is also a whole number. And again, it's very easy to tell from the diagram, because if we look at the rational number set, the whole numbers circle is inside of the rational numbers section, meaning if something is a rational number, it could also be a whole number. Does it have to be a whole number? No, there are lots of rational numbers that aren't whole numbers, but the statement says no rational numbers are whole numbers, and there are rational numbers that are whole numbers, like the number 1.